Good morning, everyone. This is sheet 8 covering the topic related to lecture 9. So let's start with first question. An FM transmitter transmitting at 100 MHz illuminates a two-wire cable in a product at a distance of 300 meters away. The transmitter is transmitting an average power of 10 watt and the antenna has a gain in the direction of the product of 20 dB. The cable is 30 cm in length and the wires are separated by 5 cm. The cable per unit length capacitance is 20 picofarad per meter. Determine the maximum induced voltage at the cable endpoints if the cable is terminated in 100 volt resistors at both ends. So first thing we need to do is drawing the circuit by understanding what the question means. So first of all we draw the circle in order to get the voltage at the end of the both resistors, which is equal to 100 ohm. So we need to get the value of Vs and Vl. So since the required is to get the induced voltage, so we are dealing with a transmission line who got an electromagnetic field. We express magnetic field as a voltage which is equal to J omega mu Ls H normal, and we express electric field as a current source which is equal to J omega C Ls electric field incident, and in which it is the transverse. So from givens, the question gives us a frequency equal to 100 MHz and the distance is equal to 300. The power transmitted from the antenna is equal to 10 watt. The gain is equal to 20 dB, and now we need to convert it to absolute value, which is equal to 10 power 20 over 10. The length is given as 30 cm. We need to convert all the units to a standard units, so we multiply by 10 power negative 2 in order to get it in meter. The distance between the two wires is equal to 5 times 10 power negative 2 meter, and it is given the capacitance is equal to 20 picofarad per meter. So now we need to get the value of the electric field. So electric field is given equal to square root 60 power transmitted multiplies by gain, all square root divided by the distance. So we substitute these unknowns by these values and we get the value of the electric field, which is equal to 0.816 volt per meter. Now we need to determine the values of both the magnetic field here and the electric field, in which represented by a voltage source and a current source. So now the voltage source is given as J omega mu Ls H normal, and we know the H is equal to E, the electric field, over the intrinsic impedance of air, which is equal to 120 pi or 377 ohm. So by substituting omega 2 pi f, and the frequency is given as 100 times 10 power 6, and the mu is a known, you can use it by calculator, which is equal to 4 pi to 10 power negative 7 multiply by length and the separation between them. So you get a value of J 0.026 volt, in which the value of the voltage source here. Now we need to get the value of the electrics of the current source. So it is equal to J omega C L S E. L is the length of the wire, C is the capacitance, S is the separation between the two wires, E and the electric field. We have all the unknowns here. So by using our calculator, we get the value of the current source. So it is given as 1.54 multiplied by 10 power negative 4. Then we need to determine the value of the Vs at the load 100, and we need to determine or find the value of the load at 100 ohm. So when we have two sources, we use a superposition. Now if we apply a superposition here, first by making the current source an open circuit, and let the voltage source here. So if I need the value of Vs, I get it through a voltage division. 100 over 100 plus 100 multiply this V, in which we get its value from the above. Now the same procedures if we need to get the value of VL, but be careful of this sign since the current is moving from here. So the first terminal that will enter in here is negative sign. So now you can get the value of VL by voltage division, negative 100 over total of resistance multiplied by the voltage source, in which is equal to V. Now we need to get the value of Vs and VL by letting the current source here, and the voltage source will be a short circuit. So the current here will be divided into two. Let's assume it is Is, and in the opposite direction is equal to IL. So if I need to get the current here, if I need to get Vs, so by current division equal to negative 100, as this terminal is equal to negative, so negative 100 over total current over total resistance multiplying by 100, which is equal to this value, and multiplying by the total current in this source. So again, if I need to get the value of Vs and I have a current source, the current will be divided into two terminals. Let's assume that is equal to Is. So if I need to get Vs equal Is multiply negative 100. So now I need to get the value of Is. Get the value of Is by current division. So Is is equal to negative 100 over total of resistance multiplying by I, the total current. The same procedures I am gonna take when I need to get the value of VL. So now VL is equal to negative 100 over total resistance multiplied by this resistance multiplied by total current source. So now if I need to get the value of Vs after making a superposition, I will add both values I got from here by letting the voltage source, and from here by letting or by using the current source. So 100 over 100 plus 100 multiplying by V, in which this value and V we got it from here equal to J0.026 volt. I plugged it in here, and then minus 100 over 100 plus 100 multiplied by I, in which the value of I is equal to 1.54 multiplied by 10 power negative 4, and I plugged it in here. So finally I get the induced voltage at the source, which is equal to J5.3 millivolt. And to get the value of VL, I will take this value that I got from a superposition and letting the voltage source, which is equal to negative 100 over 100 plus 100 multiplied by V. V is equal to the value of J 0.026 volt, as written here. Then the value I got from superposition by using current source only and letting the voltage source is equal to a short circuit. So I will get this value here, and I will substitute I by J 1.54 times 10 power negative 4, and finally I get the value of the induced voltage at the load, which is equal to negative 0.0207 J. And if we need the absolute, I just remove the negative sign and will be equal to 20.7 millivolt. So now let's go to a question 2. A 10 volt per meter, which represent an electric field of 100 megahertz uniform plane wave, is incident on a 2-wire line as shown in figure 1. So we have a frequency of 100 megahertz, electric field is equal to 10 volt per meter, is incident to this transmission line. So what is required is to get the value of induced voltage if the cable has a per unit length capacitance of 50 picofarad per meter. So you need to determine the value of this induced voltage after applying an electromagnetic field of 10 volt per meter, it is given the capacitance is equal to 50 picofarad per meter, while there is a 30-degree phase between the incident of the electric field and the transmission line. So all you need to do is to dissolve this component of the electric field by cosine 30 in order to get the value of the electric field incident to this transmission line. So first thing, we draw our circuit. We know that since there is an incident electromagnetic field, we express it into magnetic field and electric field. Magnetic field is expressed as a voltage source and electric field as a current source. So first, we know the electric field is transverse to the line by 30 degree. So 10 cosine 30, we get the value of electric field that incident to our line or our transmission line, and we can easily get the value of magnetic field, in which is always perpendicular to the line, by getting the value of E over eta. The value of E remains 10, not 5 root 3, as H is always perpendicular to the line. So the value of E is equal to 10 over 120 pi. We get the value of magnetic field. Now the same procedures will be taken, but you have to be able to determine the sign of negative and positive here. So when the electric field is upward, all you have to do is letting the negative sign in the left and positive sign to the right, and always the magnetic field will be and the electric field will be downward, in which represent the current source. So now we need to get the value of V induced and I induced. So first, V induced is equal to J omega mu SLH. So omega equal to 2 pi f, the frequency is equal to 100 megahertz, multiplied by mu, which is a constant, S is the distance between the two wires, which is equal to 1 by 10 power negative 2 meter. Length of the wire is equal to 10 multiplied by 10 power negative 2 meter. And H is the magnetic field, which is equal to 0.027. Now we get the value of V induced. So let's get the value of the current source here, I induced. It's equal to J omega C S L E. C is the capacitance given as 50 picofarad, and substitute by the values of S, distance between two wires, L, the length of the wire, E is equal to the electric field. And now again the same procedures will be applied. So first we will make a superposition first by using voltage source. Now I need to get the value of this V. So the current will pass here. The first thing will enter is the negative sign. So negative 50 over total resistance, which is equal to 50 plus 50, multiplied by the source voltage, which is the V induced. So now by applying superposition and using the current source and the voltage source is converted to a short circuit. So V, I need the value of this V. The current will be classified into two terminals, which will pass through this wire, and I current in which pass through this wire. So I need to focus on this one. So it is equal to negative I will name it IV, negative IV multiplied by 50 ohm. So if I need to get the value of IV by using a current division, which is equal to 50 over 50 plus 50 multiplied by I induced, which is the current source, multiplied by this ohm, this resistance. So finally I just put this and add it to this. So we will get the final value is equal to negative J 17.3 millivolt. Now finally for question 3, 100 megahertz. So if our frequency is equal to 100 megahertz, an electric field is equal to 10 volt per meter. Uniform plane wave is propagating parallel to an air-field two-wire transmission line. So now we can declare this problem is to get the value of induced voltage after applying an electromagnetic field to a transmission line. So the electric field is in the plane of the two wires, in which is parallel to the wire. Find or compute the magnitude of the voltage induced across the 50 volt load. So all we need to do is to get the value of induced voltage here. Since this problem deals with induced voltage, so we need to convert our transmission line. Since it is applied electromagnetic field, so we need to convert or to apply a voltage source and the current source, and to draw our circuit as shown. So this is the current voltage source V, which is equal to J omega mu L S H, and our current source, which is equal to J omega C L S E. And you need to know the value of induced voltage here after applying an electric field of a value 10 volt per meter. And we can easily get the value of magnetic field by E over eta. Eta is intrinsic impedance, which is equal to 120 pi So we get the value of H, which is equal to 0.0265 ampere per meter. Now we need to get the value of this voltage source and the value of the current source. So now we can easily get the value of V. L is the length of the wire and is given as 1 meter. S is the distance between two transmission lines. H, we get it, which is equal to 0.0265, and it represents the magnetic field. Now we can get the value of V, which is equal to J0.021. Now I need to get the value of the current source, which is equal to J omega C LSE. C is not given, so I can get it by this formula, which is equal to 1 over mu ZC. ZC is given as the characteristic impedance is equal to 300 ohm. So I can substitute it in here and get the value of the capacitance and plug it in here and substitute to get the value of the current, which is equal to 69.7 multiplied 10 power negative 6 ampere. So by making a superposition, the current source, if I letting the voltage source, the current source will be an open circuit. So I can get the value of V out by using a voltage source. Then by letting the current source and get the value of V out and adding them together, I get this formula, negative 50 over 150 multiplied by V, in which I get it by this value. As well as if I apply the current source, I will get this formula, and I here is equal to 69.7 multiplied by 10 power negative 6. After substituting those formulas, I can get the value of induced voltage, which is equal to negative J9.3 millivolt. Thanks for watching.